Hello everyone, I'm Sebastian Y, and this is Managerial Economics. In this video, we're going to introduce the concept of elasticity and discuss the own price elasticity of demand. Elasticity measures the responsiveness of one variable to changes in another. This is a very useful concept for a manager because we want to be able to predict what will happen when we change the price or when some other variable changes. The mathematical definition for a general elasticity is the percent change in y divided by the percent change in x. Here, y and x are just any variables. We're going to be zeroing in on ones that are connected with the demand curve, but they definitely don't have to be. In this equation, the triangles are the Greek letter delta, which means change, not only just in economics, but in all kinds of contexts. We are going to be focusing on three different elasticities: the own price elasticity of demand, the cross price elasticity of demand, and the income elasticity of demand. We're going to start with the own price elasticity. The own price elasticity of demand, which we sometimes just call the price elasticity, is the responsiveness of the quantity demanded to a change in a good's own price. Mathematically, we write that as the percentage change in the quantity demanded divided by the percentage change in the price. Once we divide this out, this is going to tell us what is the percent change in quantity that results from a 1% change in the price. When we go about actually calculating this from our demand functions, we're going to do a little bit of algebra here to make this easier to calculate when we have a demand function. We will use the definition of the percent change in x is the change in x divided by the current level of x. I'm going to plug that into our equation here. So the percent change in quantity demanded becomes just the change in quantity demanded divided by the quantity of x divided by the change in price divided by the current price. From here, we will use the rules for dividing fractions. We multiply by the reciprocal. So we take our top fraction, we leave that alone, and we multiply that by px over delta px. From here, we can use the commutative property to move things around to be a little bit more convenient. So we get delta qxd over delta px times px over qx. This should look pretty familiar. Change in quantity divided by change in price, that's just a slope, and px over qx is just the ratio of the current price and quantity. I'm going to take this a step further. When we make these deltas, these changes, infinitesimally small, get them smaller and smaller and smaller and smaller, these changes turn into a derivative. And specifically, since our demand functions have lots of different variables in them, they're going to be partial derivatives. So I'm going to change this into dqxd dpx times px over qx. And this is the definition that we are going to use to calculate elasticity from our demand functions. Remember to use the curly d's for partial derivatives here. Note now that px and qx are always positive numbers. It's impossible to have a negative price or quantity, and that the derivative with respect to price is always going to be negative. That's the law of demand, which means that our overall price elasticity always has to be negative. We're going to return to our example beer demand function from a few videos ago and calculate the price elasticity of demand. Since this is the own price elasticity, the first thing we need to do is get the partial derivative with respect to PB. This is relatively simple for this demand function because PB only appears in one part of the demand function. The partial derivative makes everything else go to 0. So all we're left with is negative 10 for the derivative. From there, all we need to do is plug in the price of beer divided by the quantity of beer. Let's use our equilibrium values that we found in the last video, which were PB is 50 and QB is 400. So what we're going to get is negative 10 times 50 divided by 400, which is negative 5/4. That's equivalent also to negative 1.25. What this means is that for a 1% increase in the price, the quantity demanded is going to go down by 1.25%. Let's put this number in a little bit of context. When we see the own price elasticity, the thing that we want to do is take the absolute value and then compare that to 1. If the absolute value of the price elasticity of demand is greater than 1, we say that the demand curve is elastic, that it is relatively responsive to price changes. This means that the quantity demanded change is bigger than the corresponding percent price change. If the absolute value is less than 1, we say that it is inelastic, that it is not very responsive to price. In this case, the percent change in quantity is going to be smaller than the percent change in price. And finally, if it is equal to 1, that we say it is unit elastic. This means that the percent change in quantity is exactly the same as the percent change in price. In our example, the elasticity was negative 1.25, so bigger in absolute value than 1. So we would say that at that point, our demand curve is elastic. I want to call a little bit more attention to this equation right here. Our demand function is linear in price. When we graphed it, it was a straight line. That means that derivative part never changes. It's negative 10 no matter what. But what does change is the ratio of PB to QB. When price is low, quantity is high, and so elasticity is going to be smaller. It's going to be more inelastic. When price is high and quantity is low, it's going to be more elastic. So what this tells us is that for a linear demand curve, even though the slope is the same the whole way down, the elasticity is changing. In this graph, we can see a few examples of this. At 45, our elasticity is 1, and so this is where we are unit elastic. When price is below that and quantity is above 450, somewhere like 30 and 600, we have elasticity with absolute value less than 1. So down in this part, we have inelastic demand. When the price is above 45 and the quantity is below 450, we have points like this one right here with elasticity bigger than 1, or elastic demand. The point that we looked at just a minute ago was right here at 50, and you can see that is on the elastic side of the demand curve, which is exactly what we showed. The last thing I want to talk about here is the relationship between price elasticity and total revenue. We define total revenue as the price times the quantity. This is just the total amount of money that's passing from the buyers to the sellers. Total revenue has a close relationship with elasticity, which we can see from the graph. On a graph, we can calculate total revenue as a rectangle. Let's suppose the price is 75 and the quantity is 150. Our revenue is going to be the area of this rectangle right here. If we lower the price down to 60, the revenue becomes this rectangle. We can see that that is substantially larger than the previous one when the price was 75. When demand is elastic, revenue can be increased by lowering the price. If we look over here when the price is 15, and then look at raising the price up to 30, we can see that there's also a gain in revenue. The rectangle when the price is 30 is much larger than the one at 15. This is in the inelastic part of the demand curve. When demand is inelastic, we can increase revenue by increasing the price because the relative loss in quantity is not so bad. Whereas when it's elastic, lowering the price is going to be better because we get a substantial increase in quantity. What we see from this is that revenue increases as we move towards the middle where the elasticity is -1, or it's unit elastic. And so that is the point where revenue is going to be the highest. Let's talk a little bit more about revenue. We define marginal revenue as the increase in total revenue when quantity increases. Of course, when quantity increases, price must come down. That's the law of demand. This is the first time we are using the word marginal, and whenever you hear the word marginal, we're talking about what happens when something has a small change, and whenever we think about small changes, we need to think about derivatives. So marginal means derivative. The marginal revenue is the derivative of the total revenue function. But it's the derivative with respect to quantity, because we're talking about increasing the quantity. So we need to write everything in terms of quantity, including the price. This is one of those times where we're going to need the inverse demand function. In the last video, we figured out an inverse demand function for our example, which was PB equals 90 minus QBD over 10. That means our total revenue is going to be 90 minus QBD over 10 times QB. I'm going to distribute that through. And so we get 90 QB minus QB over 10. The QB is going to be squared. I'm going to drop the D for now, since we're just talking about the total revenue. To get the marginal revenue, let's take the derivative. So the derivative of 90 QB minus QB squared over 10, we can split that into two parts. Do the first part. Derivative of 90 QB is 90. The derivative of QB squared over 10, the 2 comes down, so we get minus 2 QB. In the exponent, 2 minus 1 is 1, so that just drops out. It's divided by 10. So what we get is 90 minus QB over 5. That 2 and 10 reduce down. As long as marginal revenue is positive, increasing output will increase revenue. So how far does that go? Well, it goes until marginal revenue equals 0. Where does that happen? 90 minus QB over 5 equals 0. Add QB to both sides. Multiply both sides by 5, and we get QB equals 450. So revenue is maximized at a quantity of 450. If we go back to our elasticity graph, we can see that's exactly where it is unit elastic. Another way of thinking about this is if we look back at our total revenue function, it's a parabola. And what we're doing by setting the derivative equal to 0 is just finding the top of that parabola. And setting the marginal revenue equal to 0 is just the first order condition of the total revenue function, which is what we did back in the math review video. That's where we'll leave it for the own price elasticity. In the next video, we'll wrap up with 2 other kinds of elasticity and a few applications.